Today we're going to look at data and talk about how we sort of talk about this on a scatter plot and maybe some different things we can notice and talk about with the data. So let's say we're given this set of data here. I just made it up. It's not true at all. And let's say that our X value is going to represent the temperature outside, and the Y value is going to represent the number of ice creams, I don't know, ice cream cones that a stand sells, whatever. One of the things that we should be able to do is we should be able to take this data and we should be able to construct a scatter plot. A scatter plot is simply taking this data and plotting it onto the coordinate plane. Now, obviously, the majority of the time that we look at a coordinate plane, we're talking about a 10 by 10 grid. And there's no way we're going to fit this. The other thing that we need to consider is in situations like I-step testing, we don't have a lot of extra time to make a super detailed grid. We want to do enough that we can get the information that we need and answer what we need to answer. So I'm going to sort of fold my paper here so I can get it to fit over with my setup. Okay, so we should recognize that all of these values are positive. So when we go to make our scatter plot, the only thing that's really important to us is quadrant 1, where all of our values are positive, right? The rest of the coordinate plane we don't really need. The other thing is that we don't need to start numbering at 0. If I'm numbering from 0 to 88, that's going to take me forever. So let's just start numbering further out. So we know we need to get a picture from 67 all the way up until 88. Now, what you can't do is make a mark and do 67 and then make a next mark and do 71. You need to make sure that you're counting as an even count. So from 67 to 88, I'm looking at over 20 marks. So maybe I decide to count by 2s so I don't have to make as many, right? So maybe I start at 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88. Right? And maybe all I do is mark this as 66. I can remember in my own brain that I'm counting by 2s. If you need to label every one, you can, but again, that's going to take up time. Okay, then on my y-axis, right, I need to get from 82 to 115. That's a lot farther. So again, I'm not going to start at 0, but maybe I decide to count by 5s. So maybe I'll start at 80, 85, 90, 95, 100, 105, 110, 115, right? And maybe I'll just mark, okay, this is 80. I know that this is my 115. I know that I'm counting by 5, whatever, okay? And then I can go through and I can plot this data. So I want to make the point 67, 82, 71, so this was 66, 68, 70. So if I want 71 in here, I want 71, 93. So maybe somewhere up here. Again, it doesn't have to be perfect enough that we can sort of get an idea of what's going on. I want 85, so 66, 68, 70, 72, 74, 76, 78, 80, 82, 84. So here's 85. And again, you could take the time to number them all so you don't have to count. It's not too hard for me to sort of count backwards, so that could depend on maybe what your skill set is. Okay, so I have 100 up here. And then I have 88, 115. Okay, I can then look at this data and I can decide some things about it. One of the things that I could decide is if this is linear or not. So to tell if the data is linear, it does not need to make a perfectly straight line. We just want to recognize something that's making a general upward line motion. So even though these points are a little bit further off, we're still generally close to a line. So we would say that this is a linear representation of the data. A nonlinear data would have some marks kind of going, right? No way I can use a line to represent this info. I sort of got stuff everywhere. Okay. We can also talk about if it's a positive association or a negative association. If the line is going uphill, we would say that it's positive. If it's going downhill, we would say that it's negative. So you're going to look at a set of data, make your own scatter plot, and then talk a little bit about it.